Two-sample t-hypothesis test. We use two-sample t-hypothesis test if we want to compare that there is a significant difference between two groups that are independent. So if we have, let's say, a team, two teams in your organization. One team took a training program that you asked them to take, and the other team didn't take it. And you want to find out whether the team that took the training actually was way better off in terms of productivity than the other team that didn't take the training. So what you can do is you can use a two-sample t-hypothesis test to say, hey, what is the mean productivity metric? In this case, let's say you're a software company, then your mean productivity metric could be how much bugs are resolved, how quickly they are resolved for the customers, and for one team versus some other team, right? So you could come up with various mean metrics that, not mean metrics, but metrics that are average or mean that you could measure productivity difference between two teams. Or if you want to measure one drug, how it is performing on one group of people versus the drug performing differently on another group of people. Yeah. So if you have two groups of people, you could test a drug and its effectivity on one group and check whether they actually had a positive impact on that metric or not. So now we know if you want to compare two groups and check if there is a significant difference, we can use a two-sample t-hypothesis test. Yeah. Like we've done in the one-sample t-hypothesis test, we will do the same three steps. With these three steps, we can actually derive and make a decision whether there is a significant difference or there is none. So the first step is we create a null hypothesis. The null hypothesis basically says there is no difference, meaning status quo, preserve the status quo, which means that the population mean difference, my hypothesis is that it's 0. So if x1 was the mean metric for group 1 and x2 was the mean productivity metric for group 2, then I'm saying that there is no difference, meaning x1 minus x2 is equal to 0. Yeah. So x1 bar minus x2 bar is equal to 0. Yeah. So if x1 bar and x2 bar are my productivity metrics. So if I have to find evidence against my null hypothesis to go to alternate hypothesis, which is basically saying, yes, there is a significant difference. This team which did take the training, let's say this team did take the training, had a significant impact when it comes to productivity. So then what you could say that, yes, there was a big impact. So how we calculate, the next step is we calculate using the sample. We look at both of these two samples of group 1 and group 2. We look at various metrics. We find out what is their mean of sample 1. We call it x1 bar. Mean of sample 2, x2 bar. Standard deviation of sample 1, std underscore x1. N1 is the number of samples in group 1. And likewise for group 2. So we have the mean of the first group, mean of the second group. We have the hypothesized population mean difference, which is 0. Which is set here, and then we have the standard deviation of the first group squared divided by the number of items, number of people in that group. Standard deviation of the second group squared divided by number of people in the second group, the square root of the whole thing. So now then we get our two-sample t. This is super important because this we need to now find out how rare is this. Yeah. So we need to find out how rare is this by calculating the p-value. So we calculate the p-value. And for calculating the p-value, what we'd have to do is find out, say, hey, if this was a billion t-values for this statistic, where is my two-sample t in this curve? Is it extreme and rare, meaning it's right here, or is it like, hey, it's not rare and it's somewhere right here? So what we do is we have to get a billion such standard t distribution values and then calculate the p-value from it. But for calculating the p-value, or for even getting a billion such data points of standard t distribution, we first need degrees of freedom. The degree of freedom is not a simple n minus 1 because now we have two groups, right? And they might have their own standard deviations. They could have different number of items in those groups. So degree of freedom here for two groups would be this complex formula, right? So which is standard deviation of the first group squared divided by n1, number of items of people in this group, plus standard deviation of the group 2 squared divided by n2, the whole thing squared. Divide this whole term by standard deviation of group 1 squared by n1, the whole thing squared, multiplied by n1 minus 1, same thing plus n2 here. So keep in mind that n1 and n2 can be different. Standard deviation of these two groups could be different. So this gives us, this formula gives us the degree of freedom. Using the degree of freedom, we can then get, for this degree of freedom, a billion such data points. When we get a billion such data points, we can then plot saying, hey, let's say my t value here was around 3.5, 3.6, yeah? And we get, like, let's say, we get this one from -4, -5 to +5, and then we get our t value somewhere here, which is plus 3.6. What that means is that we can then add up all of these, from all of these billion data points of t values, we can find out all of those values that are greater than 3.6, which is our two sample t statistic, and then find out its proportion compared to this billion data points. So that is the probability of finding anything rare greater than or equal to the two sample t that we found. So here we can find that, hey, maybe in this case, if we did this in a hypothetical scenario, it would come up to be like 0.03, or this is 3%, yeah? So if this is 3%, then we know, hey, there's only 3% chance that there could be another two sample t from a billion data points to actually be greater than or equal to my sample, two sample t that I've observed. So with that p-value, we can actually make a decision. For that decision, we just need one more thing, which is like, what is our threshold? It could be that your threshold is 95%, it could be that your threshold is 99%. So once you know your threshold, you can find out, like if it's your threshold is 95%, then you will accept anything above or less than 5%, meaning you will only act if there is numbers less than 5%. In this case, we got 3.6%, yeah? So our p-value, 3.6%, is less than 5%. It is less than 5%. So this is evidence against the null. And that means we should reject the null hypothesis. When we reject the null hypothesis, accept the alternate hypothesis. What does that mean? That means that we have to reject the fact that there is no difference. It means there is a significant difference between these two groups in terms of their productivity. So now we can look at these two samples and actually say that, hey, these two groups of people in your team, there is a significant difference in productivity using a two-sample t hypothesis test. Yeah? There are many such examples when you want to compare two groups and you've done something to one group and not done something to some other group. And there is a lot of similarity here with A/B testing, but there are also difference between what we've covered here and A/B testing. Right? So A/B testing, there's also a big aspect of randomization in terms of which person is in this group and which person is not in this group. So there is no such thing other than it expects these two samples to be independent, yeah, but not necessarily expects them to be randomly assigned. And there are various other objectives why A/B test is used, but you see a lot of similarities. You see group 1, you see group 2, you start to see if there is differences. In A/B testing, we start to see which one is way better, right? Here we are trying to just see, improve or disprove our hypothesis if there's a difference, yeah? So this is pretty good in terms of telling us if there is a difference, yeah? And we're not even doing any causal inference here, yeah, which we do in A/B test, but there's lots of commonalities between creating a null hypothesis, alternate hypothesis, calculating for our two groups, two sample t, using the two sample t, then we find out like how rare it is and use the p-value and our confidence interval and threshold to make a decision whether we accept or reject the null hypothesis. That is two sample t hypothesis testing. Thanks.